Welcome to the deep dive. Ever stop to think how words, just sounds really, or marks on a screen, somehow get you to do something? Like someone says, the dog's barking, and maybe you get up, close the door.
Yeah.
How does that happen? It's a surprisingly deep question, and that's what we're really digging into today. We're basing this on a really interesting piece called How Does Language Map to Action? Well, it's part philosophy, part cognitive science.
Bit of both, yeah.
And it lays out this, honestly, quite speculative framework. So our goal today is to unpack the core ideas here. It challenges some pretty standard ways of thinking about memory, about how our minds work.
It really does.
And get ready, because there are some genuinely surprising parallels drawn between, well, us, the human brain, and large language models, LLMs. Might make you rethink things a bit.
Definitely some aha moments, I think.
So let's kick things off with that main puzzle.
Yeah.
Right? How does abstract language, just words, translate into actual physical action? That leap from hearing a phrase to, say, moving your body, it seems almost magical, doesn't it?
It does, and it touches on really fundamental stuff. Our cognitive architecture, perception, brain states, even how memory works.
Oh, it's not just a small question.
Oh, not at all.
Yeah.
It's what many in the field call a hard problem, because you're dealing with very distinct brain states, right?
Right.
You've got the language system processing the words themselves, then maybe perceptual systems, what you see or hear, and then the motor system ready to make you move.
All separate things.
Pretty much. And the challenge is mapping this self-contained language structure with its own grammar and rules, mapping that onto the sensor-motor systems that actually interact with the world.
How do they even talk to each other?
Exactly. It's almost like having two completely different operating systems, different code, different logic, and you're trying to make them work together without a shared underlying architecture.
Yet somehow
our brains pull it off constantly. It's fascinating.
Okay, so given that huge challenge, the article then throws another curveball. It suggests that language itself, maybe it operates mostly on its own.
Kind of autonomously, yeah.
Meaning, it's just about the relationships between words, their structure, not necessarily tied directly to, say, seeing something or doing something.
That's the proposition, that the core of language processing might be purely structural.
And this is where the LLMs come in again, right?
Yeah.
Because models like GPT, well, they're amazing at language.
Incredible, yeah.
Summarizing, writing, translating. All without a body, without senses in the human way, without actually experiencing the world, just text patterns.
That's a really key parallel the author draws. Think of language like a game, chess, maybe.
Okay.
You can get incredibly good at chess, understand all the rules, the strategies, the patterns,
Yeah.
without ever relating it to, I don't know, real-world battles or emotions.
It still works within its own system.
Exactly. It exists in its own sort of ecosystem of rules and possibilities, which naturally leads to the big question.
If it's so self-contained, how does it ever connect back to our actual lives? How does it make us close that door when the dog barks?
That's the million-dollar question, isn't it? If it's its own game, how does it influence the player?
And the paper goes even deeper, challenging something most of us probably just assume is true, that our brains process facts about the world.
Yeah, this is quite a radical turn. The argument is, well, maybe we don't directly access facts about the world.
What do we access then?
Just brain states. Now, these states might, correlate strongly with what's happening outside,
Okay.
but they aren't direct representations of external facts. They're described more like potentialities.
Potentialities, like a readiness to do something.
Sort of. A predisposition for a certain action or response. Think of it maybe like a piano.
A piano.
Yeah, imagine all the keys are tuned, ready to trigger different actions or internal states. Pressing a key doesn't inherently mean something external on its own. It just creates a vibration, a state that could influence another system if that other system is tuned to listen,
So it's about potential connections, potential interactions, not just storing facts.
Exactly. Potential for interaction, readiness to act, not a database of world truths.
Okay, so if we're dealing with these internal brain states, these potentialities, how does language manage to press the right key on that piano, so to speak? How does it trigger the right action?
Now we get back to the really interesting LLM parallels. Because the cognitive theory laid out here, it draws some very direct comparisons.
This is the part that really grabbed me. There are three main parallels mentioned, right?
Yeah.
About memory.
Yes, precisely. And they really challenge how we usually think about memory.
Okay, what's the first one?
So first, the training phase of an LLM, where it learns patterns from huge amounts of text data.
Yeah.
That's compared to the brain fine-tuning weights, basically adjusting how strongly neurons are connected based on experience. It's like long-term learning or memory formation.
Okay, fine-tuning weights. Got it. What's second?
Second is autoregressive generation. That's just a technical term for how an LLM produces text, predicting the next word based on the words that came just before it in that specific conversation.
Like it's continuing the flow.
Exactly. And that's likened to our sort of working memory, the brain's current conversational flow guiding the next idea or token. What's active right now shapes what comes next.
Makes sense. And the third one?
In-context learning. This is how you can sort of temporarily teach an LLM something new just for that one chat session, right?
Like defining a new word for it.
Right. And that mirrors how we seem to temporarily integrate new information into our ongoing thought process.
Wow. So training is like long-term memory formation, generation is like working memory flow, and in-context learning is like temporary adaptation.
That's the analogy being drawn. And one of the most striking speculations based on this is that maybe humans also do not retrieve data from a database.
Wait, no retrieval? Like we don't pull up memories?
That's the provocative idea. Instead of retrieving stored information, maybe we generate responses from a constantly evolving contextual space, just like LLMs.
So remembering isn't like looking something up, it's more like creating it on the fly based on the situation.
Pretty much. A dynamic generation process guided by context rather than pulling a static file. It really challenges that memory as a filing cabinet idea.
That leads right into what feels like the boldest claim here, that maybe the brain doesn't do retrieval at all. We think of memory like a vast library, right? You need something, you go find the right book, pull it off the shelf. That's retrieval.
That's the classic model, yeah.
But this framework says maybe that whole library metaphor is just wrong.
It suggests it might be. Instead of accessing a library, the idea is the brain is constantly fine-tuning.
There's that fine-tuning again.
Yeah, it keeps coming back. Your experiences continually adjust those neural weights, those connections. So memories aren't stored as distinct items to be retrieved.
They exist how then?
More like potential responses encoded in neural weights. The potential to generate a certain thought or action is encoded in the structure itself.
Which is very different from standard psychology models, right?
Yeah.
That usually assumes some kind of active search and retrieval process.
Oh, absolutely. This proposes a much more generative, maybe reactive model. What you remember is actually constructed or activated in the moment, heavily influenced by your current context and those tuned weights.
And this rethinking doesn't just apply to long-term memory, does it? It also challenges the standard view of working memory.
Correct. That classic idea of working memory being, a very short-term buffer, maybe holding 7 plus or minus 2 items.
Yeah, the magic number 7 thing. For just a few seconds.
Right. This perspective sort of recasts working memory. It's less of a tiny, time-limited buffer and more like continuous context.
Continuous context, what does that mean?
It means that information from the recent past doesn't just abruptly disappear. Its influence decays gradually over time. But even older information can still subtly shape your current thought generation. It's not an all-or-nothing buffer.
And that links back to the LLMs too, doesn't it? How they pay less attention to older parts of the conversation, but don't forget it entirely.
Precisely. It mirrors how LLMs reduce, but don't eliminate, the attention weights they give to earlier parts of the input sequence. It still informs the output.
So if working memory isn't just this tiny fleeting buffer, but more of a gradually fading context, how does that change how we think about focus or learning?
Well, it suggests a more fluid boundary between active thought and recent history, doesn't it? Maybe learning is less about jamming things into a short-term box and more about integrating them smoothly into this ongoing contextual flow.
Okay, so let's try and tie this together. We have this idea of fine-tuning instead of storing discrete memories, and continuous context instead of a tiny working memory buffer. How does this give us a new picture of our overall memory system using that LLM analogy?
It paints a picture of a kind of dual architecture, but maybe not in the way we traditionally thought. You have the fixed weights.
The long-term stuff.
Yeah, analogous to the patterns learned over time encoded in the connections, like the LLM's huge training data set. That's its foundation.
Okay.
Then you have the context window. This is the current flow of information, the active processing, like the current chat session you're having with an LLM.
Which is like our short-term active thinking.
Exactly. And the core idea, connecting back to the no retrieval point, is that the brain, much like the LLM, isn't recalling facts directly from the fixed weights.
It's generating them.
It's generating sequences, thoughts, ideas, potential actions guided by the current context window, using the patterns encoded in those underlying weights.
So memory is much more dynamic, maybe even creative, than just being a storage warehouse.
That's the implication, yes. Less static storage, more dynamic generation.
So putting all this together, what are the big takeaways for understanding our own minds? Where does this leave us?
Well, it suggests we're making huge strides, especially in understanding the language part of the equation. The success of LLMs has, kind of accidentally, given us powerful new models for thinking about symbolic processing.
Right.
But as the article concludes, we still lack equivalent frameworks for perception and motor control. We have good models for the language game, maybe.
But not for how the game connects to the real world of seeing, hearing, moving.
Exactly. That integration piece, mapping the symbols back to action, grounding language and sensorimotor experience, that's still the major frontier. That's the part of the cognitive architecture we still need to complete.
Wow. Okay, that was quite a deep dive indeed. We've covered some really mind-bending ideas. Language maybe being its own autonomous system. The brain operating in ways surprisingly similar to LLMs. This radical idea of memory being generated through fine-tuning, not just retrieved.
And the big remaining puzzle of how it all connects to actual action.
Right. So here's maybe a final thought for you, the listener, to chew on as you go about your day. If our memories aren't fixed things, things we pull out of storage, but are actually generated, constructed in the moment based on this ever-shifting context and those fine-tuned neural pathways. What does that really imply? What does it mean for how fluid our personal stories might be? Or even for our understanding of truth itself if it's always being generated anew?
Okay.
Something to ponder.